Hi, we are KAIST undergraduate students, and this time we will talk about the density functional theory. After De Broglie and Einstein, we noticed wave-particle duality due to this electron double slit experiment, and we tried to calculate wave function and energy of matter by using this Schrödinger equation. Like this particle in a box case, we can calculate quantized energy. However, when we solve this equation, we need a special condition like these terms. Also, there are so many electrons in general case. Each electron has their own wave function, so it is impossible to consider all of these terms. So, we regard the individual electrons as just one lump, like this. It seems like density area. To express this model, we need some approximations. Before we consider it, the general Hamiltonian is same as this, and we will change this equation by using approximations. First one is Born-Oppenheimer approximation. Nuclei are much heavier than electrons, so we can think nuclei are stationary from the perspective of electrons. If we do this, two nuclei terms can be removed. However, we can't solve it completely. Second one is Hartree-Fock approximation. This approximation assumes that individual electrons move independently of each other, and all electrons have their own spin orbital. Electrons' total wave function can be expressed in this later determinant. It comes from power exclusion principle, and each row means electron. If we want to find the lowest energy state of this set, we need a self-consistent field method. Self-consistent field method is like this. If there are n electrons, each electron fills the mean field of other n-1 electrons. So, potential energy can be written as this equation. Now, we can calculate Hamiltonian and Schrödinger equation. After getting first electron wave function, we can repeat this process on second electron using result of first wave function. The mean field will be revised again, so total value can be closest to real value. This is a kind of feedback process. Third one is linear combination of atomic orbitals approximation. After Hartree-Fock approximation, there are so many Hartree-Fock differential equations of individual electrons. So we can change it in algebraic form to calculate easily. This equation is the linear combination form of molecular orbitals wave function. Through these three approximations, we can derive a Rutahnor equation.
However, this model does not contain some terms in real behavior. So there is new and developed one, density functional theory. Before explaining density functional theory, let's see the Hohenberg-Kohn theorem first. There are two theorems. First is ground state energy is unique functional of electron density. Second one is electron density that minimizes total energy is the exact ground state density. These two theorems mean that electron density of any system determines all ground state properties of the system, and if we know the density, we can find the energy of ground state. Let's see the density function theory. In density function theory, electrons affect and are correlated each other unlike Hartree-Fock model. This is the biggest difference of DFT from Hartree-Fock model. Compare the Hartree-Fock models and DFT models energy equation. Hartree-Fock model's energy has four energy terms: kinetic energy, electronuclear potential energy, Coulomb energy, and exchange energy. In DFT model's energy, the first three of these terms are same, whereas the Hartree-Fock's exchange energy is replaced by an exchange correlation energy. The exchange correlation energy shows that DFT model think the electrons affect and are correlated each other. Except kinetic energy, all components depend on the total electron density. Then, each energy can be written in terms of density. Finally, DFT model treats many electrons as electrical density and considers electron correlation. This result can describe molecular system better than Hartree-Fock model. Then, how is the DFT used? DFT is used well in molecular-based simulation research. For example, we can see the chemical reactions. This animation shows the processes of SN2 reaction and DL-center reaction. These processes are calculated by DFT-based program. We can also find each energy state of reaction by using DFT calculation. Then, we can simulate which structure or which material is better for reaction. Today, we talk about the density function theory and some approximations which need to DFT calculation. And we also learn how the theory can be used in research. This is Zen. I hope you guys enjoyed this YouTube. Thank you. And this is Jeongwon and Youngho. Bye.